So this is the 10th video. I talked about 6 previous coronavirus, including the most genetically related SARS. So now I will discuss the SARS2 adaptation pattern. And the objective is to come up with a strategy against this virus. And this is very important. The most important thing is coming now about how this virus is using sialic acid. It's the weakest point in the infection, in my opinion, is that area. So you can support this project. I hope I could realize these nanomaterials and they could have effective remedies against this virus. So let's talk about this SARS2 infection pattern or adaptation pattern. I tried to show you 6 different viruses, including, I think, the most important one in terms of to compare SARS2 is the MERS, because MERS adapted in 2012. Actually, SARS, the first SARS is also very important, but what I'm trying to say, these viruses, the other viruses, has severe change, but SARS2 had 0. No change on its sialic acid binding domain capacity. How this became possible, and also it doesn't have any receptor binding domain high frequency mutations, 0, just very low frequency substitutions. And also it has a recombination, and that recombination enables a virus to be cleaved by furin, very good advantage for the infection. All those strangeness I'm going to show you on the genome right now. So this is the bat virus, and this bat virus is the ancestor of coronavirus. This is the sialic acid binding domain, and it has nothing changed. It's a bat coronavirus sialic acid binding domain. That's the first time we see. And this situation also not something we see in other human viruses. So there is nothing, no change. Only some low frequency mutations in this area, but also they are not related to the sialic acid binding domain. They are of the domain of the critical, they are not critical domains. So I just talked in the previous video, once we discussed the SARS, genetically related human pathogenic coronavirus, the most related. And if you recall, SARS had relatively few mutations, and then during the infections had a lot of mutations, tried to adapt. But in this receptor binding domain, the bold areas receptor binding domain, this virus had several mutations and then halt. And I'm going to explain what it means, but this virus doesn't have to mutate. So it has low frequency 2 mutations here on the receptor binding domain. They are not on critical receptor interacting residues. So this is not normal in terms of its stability. So that's the third genetical alteration in the SARS coronavirus spike protein, SARS coronavirus 2 spike protein, and those 3 quality feature of this specialty of this virus makes this virus really unique in other coronaviruses. And this area is the insert. This is the insert. So after millions of infections and almost thousands of sequences, another insert we see in those clinical isolates infecting human, or another recombination on spike protein, no, nothing. Just a one-time special event, and I'm gonna explain the logic of this, why it's an artificial introduction.